Okay, I think we can get started for today. So thanks everyone for being here again. So we have spring break coming up, and I think it's midterms week. But today's a really exciting lecture. So we'll be talking about agents. This is an area, like many of the topics in this course, that has been kind of rapidly developing very recently. So I'll try to go over some of just the key ideas to so that you can be familiar with these things. Some of you might incorporate agents into your projects. Otherwise, it's just another good thing to learn about. So if we recap what we talked about at a very high level, then we can think of these language models coupled with some inference strategy as being this kind of system that takes in some input text and gives us some output text. And if you think back a couple lectures to when we talked about reinforcement learning, I wanted to just recap this idea of the reinforcement learning setting, which was called a MDP, or Markov decision process. And if you remember, the MDP had a few different components. It had this notion of some environment, which provided a state. And then we had this policy, which took actions given the state. And then you also have a notion of reward. And the goal of reinforcement learning is to learn a policy that can maximize the reward in expectation. Okay, and so the reason that I'm recapping this is because it'll actually turn out to be very relevant to what we talk about today, which is agents. So let me just recap it a bit more just to make sure it's clear again. So here we have this Atari game, or this is the game called Pong. And you have a state here, which is an image of the Pong playing field, or whatever it's called. Um, and actually, I'm not going to put the notation here, but when you think about it, there's a kind of underlying state of the Atari system. And actually, when you see this image, it's just called an observation because you're actually not looking at the configuration of the Atari game state. All your policy gets is this kind of observation. But just for simplicity, I'll still call it a state. And then you give this to your policy, and it could take an action like down. Then you give it to the environment. This also, you'll see this named as a transition function or a transition distribution. It then actually executes this action on the Atari game playing system, and that results in a new state or a new observation, and that'll be this image here. Then you can continue this process and roll it out until the game is complete. You either win or you lose. And that's the basic setup here. And we're actually going to be using the same setup today when we talk about agents. So first, I'll go over what is an agent, at least one definition of an agent that's helpful for understanding. Then I'll go over some common agent environments, and these are going to be ones that involve language models or vision language models. Then I'll go over a few different patterns for building the agents. These will just be very basic things like how you would prompt a language model to kind of function as an agent, basic things like that. And then, especially in this first part, I'll have some examples of very simple agents. And as always, or for many of the lectures, there is this code that you could view on the course webpage. Okay, so what is an agent? So surprisingly, this question comes up a lot. So here I'm going to define an agent as just being a policy. So something which takes in a state or an observation and then gives you an action or a distribution over actions. And then as we've discussed, when you have a policy, it has to operate in some environment. So for example, if you have an agent that's trying to play Atari games, then it has to kind of operate in an environment with the Atari system. Similarly, let's say you have an agent which is like doing stuff on the internet. Then without some notion of an environment that means actually interacting with the internet, it's a kind of meaningless agent. Okay, so you have this agent or policy, which is taking actions given states, and it's doing so while interacting with an environment. And then again, we can have some notion of reward. And so perhaps the goal of designing a good agent is to have one that maximizes reward. So we'll see several concrete examples of this in today's lecture. But this is the definition we'll use, which is an agent is actually very similar or exactly the same as what we talked about in the reinforcement learning lecture. It's some policy that goes from states to actions. So what are some example environments? So here is one which was created in 2017, 2018. I'll put the link to the paper on the course website. And here it was a kind of forward-looking paper. They were coming up with these environments for different agents, and each one of them is essentially a very simple web page. So like up here, you have some web page and it's very small, but up here you have the kind of goal of the task. And then the agent has to kind of point and click, or sometimes it has to type in things and do these kind of basic operations that involve web pages. So if we look at one really simple example of this, then one task is called this click environment. And you can see here that the task description is indicated up here as text. So it says click button 1. And really, this is actually a kind of simple web page. It's literally HTML and it's running in a browser. And now your task is to click the indicated button. And I didn't put the details of the reward here, but basically the reward is you get a higher reward the faster you perform the task. So if you take a long time to click the button, then you get a lower reward. And if you like never finish, there's a timeout, I think 10 seconds, then you kind of fail the task. And so you can actually get this exact environment through this library. And so I wanted to just show you that this is very similar to what we were talking about with reinforcement learning. So here we have the environment. It's called mini WOB. So WOB stands for World of Bits, was the name of the project. And then you could basically get the observation. You can have some agent which takes in the observation. Here it's also taking in the environment just so that it can get things like the size of the screen and things like that. It gives you an action, and then you provide it to the environment, and it gives you some new observation. It could give you a reward. It could tell you whether it's terminated or not. So before I tell you about agents and give some examples of the agents, let's look like very concretely at what these different parts are. And I want to just jump right into this concrete example because, yeah, this idea of an agent and things like that, it can seem very mysterious. But if we just look at an example, hopefully I can convince you it's at least conceptually kind of simple. So for the observation here, you basically have two different options. So one option is to actually take in this screen as an image, and the environment will give you that. The other option is to represent everything as text. So this basically takes the structure of the HTML and then it gives it to you as this kind of dump of JSON. And so you could see here, for instance, that like over here we have the button and it says text 1. Um, Over here we have a button which is text 2. And so you can imagine like performing this task actually without even looking at the image and just using this as your observation. Um, And then the actions are determined by how the environment is implemented because, the environment is just this computer program. And so you have to decide which actions are supported. So here's the full list that are supported for these world of bits environments. So for example, you can like move the mouse to a given position. This one is very relevant for this task. So there's literally an action which is like click element and then some reference. So if we go back here, we can see that this reference is 4. So to solve this task, all the agent has to do is basically output an action that says click element 4 in this case. So that's the notion of observation and action for these environments. And so now let's think about like what are some agents that we could build to um, you know, solve tasks in these environments. Well, I defined an agent as just being some policy. So if we really wanted, we could just hard code our own agent for to solve this environment. So we can look at the JSON and look for the element that has text 1. Then we can get its reference, and then we could just output the action click element ref. And this would solve this environment. So if you really want to do this, there's an implementation of it in the code repository. And here's, taking the observation, and then here's creating the action. And you have some extra code to actually like make sure the action is formatted correctly and all that. So we can take a look at this, and it's called here trivial agent. And you basically have what I showed you before, and then you can call it. And there it is. And so here it's showing where it clicked, and you can see that it's clicking it and it's solving the task. So no language models, no machine learning needed. We actually have an agent that can do this web task. But of course, like, this is not a very general purpose agent. It only works for this very one narrow task. And so we want to somehow come up with a system for making agents that are more flexible so that we don't have to redesign agents for every task. So one way to do that is to incorporate a language model into the agent. So again, an agent is just something that goes from a state to an action. And then we can actually use a language model, to produce the actions given the state. And so this is what's called a language model agent or LLM agent. It's one that incorporates a language model kind of in the process of determining actions. So what would this look like? Well, if you don't want to train the model, then you have to prompt it. So here's the full picture. You again have your environment. And now since it's just a text model, we represent the page as this kind of JSON that I showed you before. And then we have a prompt, and it's kind of small. It says like, I mean, it's just one that I wrote. You're on a web page. Here are your available actions, and you describe the different actions. You see the following elements as the observation, and then task, here is your task. And the environment actually can give you this text here as text, and so you can just put that into the prompt. And now you could just call a language model. This one's calling Gemini through the API, and then you could get some output. And then you could say like, okay, if the language model output click element, then you get the element number and you make an action. Okay, so this is like this is a language model agent. And surprisingly, this is kind of similar. It's representative of the architecture that a lot of people use in most agent tasks today with language models. Of course, they're going to get kind of more complex, but the idea is, yeah, you can represent things as text and then have your language model take these actions. So here again, you could take a look at this. It's in the course page, and um, for this one, I actually used a more difficult environment because the other one it can do pretty trivially. So let's take a look at this one. So this one's really small, but basically, okay, it's really small. Yeah, okay. So this one, it tells you these different boxes that you have to click, and then you have to press submit. And so this is actually running this Gemini agent, and it's able to, yeah, basically click the boxes correctly and then press submit. And so here you can see um, what it's clicking. And again, this one is a language model or text only agent. So it's doing this using the JSON representation. And then down here, you can see the different rewards that it's getting. Um, so yeah, you have like a two-step trajectory, and then at the end, it gets this reward when it finishes. So that's the basic idea. Um, does anyone have any questions about this so far? Oh, oops. Okay, cool. So then there's one more type um, of agent that we can look at, which is called a vision language model agent. And again, the idea here is simple. So instead of having just a normal language model here, we have some way of taking in images as the observation. And so we'll actually have a whole course on these multimodal models. Um, well, we have a whole lecture. There actually is a whole course at CMU if you want. But we'll have a later lecture on these. But the basic idea is, you could come up with some way of giving the image to your language model. And so now you don't necessarily need to use this JSON representation. Now it can just take in the image, and you can see here it uses different types of actions now. It actually has to click the coordinates that correspond to the box. Um, so again, you can try doing this with Gemini. So again, we have a prompt, and yeah, now we tell it about the clicking the coordinates actions. Um, and then here's where it's calling Gemini. And Gemini has a way of, you could just provide it with an image. So now we're using the images instead of the JSON representation. So let's look at how this one does. Yeah, so this one, I had to just use the simple environment, and it looks like it's still pretty bad. Um, okay, so I got it that time. But yeah, so over here you can see where it's trying to click. And the vision model is also slower, so sometimes the API call just takes too long. Um, but anyways, if you play around with this afterwards, you'll notice that the model is actually, yeah, kind of unreliable at just like clicking in the right place. See here, it's like clicking slightly off of the box. Um, so anyways, there's these trade-offs to like operating on images versus operating on text. Mhm.
Are the coordinates like bound? Does the visual encoder give the coordinates, or does the LLM somehow generate them?
Yeah, so that's a good question. So yeah, I think part of the difficulty is that the model has to map these like, continuous coordinates uh, onto the image. So the way it's done here is up here we give the model the screen width and the screen height. So then it could kind of reason and say like, okay, the middle of the image is the height divided by two and things like that. And then just outputs numbers. Yeah. But this is an issue that we'll talk about later for like the web agents. They're also not very good at this, so at least for now, people use um, yeah, something else called set of marks that I'll talk about. Um, okay, cool. So that's a vision language model agent. And so um, this one, this is a kind of emerging category, and in some sense, it is a vision language model agent. But I'll give some examples later where you could imagine that, like, okay, what if the agent was so general that you could give it anything involved in using a computer, like just a screenshot of any application, and then your actions are also so general purpose that they're not specific to a given environment. So there are things like clicking, there are things like typing. Um, then this you might call a computer use agent, where the agent's observation space and the action space can potentially work for anything involved with a computer. And then at least, yeah, right now, typically you'll try to implement these with a vision language model in the loop. So I'll go over some examples of those later. And so to recap, we saw these three kinds of agents. Language model agents, um, assuming the language model doesn't take in vision, then those are kind of a type of text agent. Visual agents, and then computer use agents, which if you want, they could be text agents or visual. Typically, they're visual because they might take in like the screenshot of the computer. Okay, and so recently there's been a lot of interest in agents, and apparently, particularly this year, there's going to be a lot of excitement. So it's a good time to take this course. Here's a quote from the NVIDIA CEO. Um, and anyways, some like areas that are of interest here, and I'm not saying these are the only areas, they're just a few of them. One is for software engineering, and so we'll see some examples of software engineering agents that maybe you could say like, here's a GitHub PR, can you close it? Other ones that are becoming popular are for research, like compile a research report on how the AI industry has changed in the last 4 months. And we'll see an example of how you could frame something similar to this as a kind of agent task with an environment. And then these web agents. So instead of using the toy website like I showed you, what if you had an agent operating on the actual internet? Then maybe it can, if you really trust it, it can buy things for you and send mail and things like that. Um, so the next two parts are going to go over environments and then some patterns. Um, Let me just pause here. Does anyone have any questions or discussion points?
Leave 2025 as the other patients.
There's a lot of people working on it, so but we'll see some examples, and I mean they have hints of doing non-trivial things, so I think that's why there's excitement about it because yeah, it's still at a kind of turning point, and anytime something's at a turning point, it could go a variety of ways. So mhm.
You hear the kind of the main challenges that web agents are facing.
Yeah, so I can maybe just like bring some of those up as we're going through the examples. Yeah, that's a good question though. Okay, so here I want to just go through three different types of environments. So text, visual, and computer use agents. So for text environments, one common pattern is to kind of create a text environment that's specific to a particular domain. Um, and as an example, to see what I mean by that, we could consider, let's say you want to build a software engineering agent. Then by engineer an environment, we mean you have to pick what are your actions that the agent will take. So it could be like search a repository, execute code, edit a file, things like that. And then you basically have to build an environment that can implement these different actions if your agent was to call them. So you actually have to like, have some code that searches through a repository and then gives the results to the agent. Um, and so as an example, like here we could say let's say we want to find out how many commits from this person to this repository LLM lean. Then here the agent or the language model could output this code, and you could see it's wrapped in this kind of like identifier. And this basically says that this is some action that the environment should execute, should like take care of. And so then your environment would actually execute this code and return the output to the agent. And then the agent would go to the next step, and maybe it says like read output and the number of commits is there or something like that. So that's the basic idea. And this basic idea is like behind a lot of the work right now on these software engineering agents. So let's take a look at um, some actual examples. So here's one which is called SWE agent. And then any agent has to operate in some environment, as I mentioned. So this environment has this thing here, and they have this fancy term called agent computer interface. And it's basically what are the different actions that are available to the agent. Here they're actually, running the actions on a computer, and then they have to format the outputs to give back to the agent. So in this case, the agent would take in the action outputs, the task instruction, and it has things like open a path, go to a line number, search a file, and so on. And so if you haven't seen this before, and I apologize, I guess it's a bit small, but I can still talk through it. So the task that they were interested in here is like closing pull requests. So here we have, or GitHub issues. So here we have an issue for some repository. And it has the text of the issue, and then you give it to the agent. And then their agent does some kind of chain of thought here. And then you can see at the bottom, it's outputting its action. And the action is find file sessions.py. Then you give that to the environment, and the environment will kind of show you sessions.py, and it's been formatted in a nice way. So that's really the basic idea of a lot of these different software engineering environments for agents. Um, and you could imagine that like maybe for different languages or for different types of code, you actually have to build new actions to support different functionality. So for example, let's say that we wanted to search for a method inside of a class. Well, then like we have to provide that as a kind of action for the agent to take. Or let's say we wanted to use what would this be? Uh, decompiler or debugger. Then you can add in these actions so that the agent can, call a debugger or call the decompiler, things like that. Mhm.
So how is the agent or policy actually updated based on the, like, how does it change?
Yeah, yeah. So here I'm just going into the kind of basics. So I actually don't really talk about training. But the idea is, yeah, so here I'll talk about models that are just prompted. And then the idea though is that if you have rewards, then you could, in principle, apply the different techniques that we've looked at in the class. So for example, you could have some trajectory and it ends in a positive reward, and you can like save that and then do fine tuning on it. Or you could use a reinforcement learning algorithm. And yeah, these are things that people are like actively figuring out right now. Mhm. Mhm.
Since an agent uses language model internally, what is exactly the prompt that goes to that language model?
Yeah, so we'll see that later on when we talk about the agent patterns. we'll take a look. But yeah, just at a high level, you give some instruction like you are a software engineering agent, you're really good at software engineering. Then you describe the different actions. So I did that in the simple agent that I showed you. You basically describe like, okay, you have access to the search class method. Here's how you call it. Here's a few examples. Um, then you say when you output an action, format it in this way. And then that's basically the essence of it. Um, yeah, I apologize. I guess for these slides I put a lot of information, but let me just talk through this one. So this one's pretty interesting and it's from a few years ago from OpenAI and it's called Web GPT. So although this one isn't doing research like I was telling you about before, the idea is maybe somewhat similar. So here they're trying to answer questions like, why did we decide that certain words were bad and shouldn't be used in social settings? And then the idea is they want to give the agent or the model access to this environment that has like a search engine that lets you click on links, that lets you quote different sources. And so the idea is it can go search, it can go collect information from different web pages. And then at the end, it can say, okay, I'm done. I'm ready to move into the answering phase and produce my answer with the information that I've collected. So yeah, this was called Web GPT. And they actually have this, if you want to take a look at this, they have this nice answer viewer. So here's the question, and here's the answer. And then on the right here, the cool thing is they actually show the trajectory that the agent took to get to the answer. Um, so where's the starting? Yeah. So here it like does some search and then it clicks on this page. Now it's looking at the page. Now it like saves this. Okay, now it's doing some more web search. And so it's this kind of trajectory. And then eventually at the end it'll say, okay, I'm ready to answer, and then it produces this answer here. So yeah, kind of cool idea. I obviously don't know what they're using, but now OpenAI has this product called Deep Research, and it'll go and find like different citations and then compile some research report for you. So potentially some of the ideas here are relevant to that. Um, okay, so another thing you could do is web shopping. So here again, we're not considering the vision agents yet, but as we saw before, you can try to represent the web page as just text. So this was a paper called Web Shop that was really popular, and they do exactly that. So basically their environment simulates some e-commerce website, and then they have different tasks that you can perform. Like I'm looking for a small folding desk that is fully assembled. It should have a khaki wood finish and priced lower than $140. And then the model has this kind of specialized action space. You can see that it's kind of, yeah, specific to their environment. It has like choose product title. And then the agent can go and try to perform different actions to fulfill the task. Now, something I've been forgetting to put up here is the reward. And so you also have to determine like how you evaluate whether the tasks are complete or not. And so each environment has to think about that. I forgot exactly what they do here, but you could imagine that like since they built the environment themselves, they have some way of looking whether the correct thing was purchased. And then if it was, that'll give you a positive reward. If it wasn't, then you get a negative reward. So, um, Yeah, so these are the text environments. Um, can anyone think of like pros and cons, at least from the environments that I've told you about? Mhm.
The website that is more because you didn't mention like how it chooses the website. Might go to like it might put the website that we humans know is like the BS website. Like it might not know that.
Yeah,
I think that's like one con.
yeah, yeah, that's a good point. It has like if it has too few constraints, then yeah, it could go to other website, just compile information and come up with some report, and it's kind of yeah, not good for a human. Yeah. Mhm.
I think like this exposes it to a lot of prompt injection vulnerability.
Mm.
Like there could be some malicious sites, and that you embedded something over there, and when the agent copy pastes or at least references that particular site, maybe some very malicious prompt injection happens. Maybe there's some sort of forgetting going on. There could be a lot of vulnerability
Mm.
just that agent.
Yeah, yeah. So in some sense, there's similar flavor where, yeah, the agent could encounter bad information or could encounter, yeah, some malicious information. And so there's kind of new angles of safety or security with these web agents. Yeah. Mhm. Mhm.
Are we initiating an LLM call? Or what is the difference between when am I getting rewarded? Like what action am I taking? And is it based on an LLM call or the policy that's
Yeah. Yeah, so the policy will be some mapping between the observation and the action. And so in their case, the observation, I think, is like the history of the action so far. So you start out with just the question, then maybe you've clicked on a web page, and then it saves like one link, and all of this just gets like built up. And then at each given time, yeah, you're giving all of this information to a language model, and then the language model is outputting some action that will be taken next. So the policy is taking the action, yeah. And then the way that the policy is implemented is to call an LLM to get the action. Yeah. Yeah. So policy is kind of conceptual abstract thing, and then the LLM is like how you're achieving the policy. Does that make sense?
is like in a general entity have a policy for every possible state and you could know what action you could take at a given moment of time. But in this case, because we have an LLM and we're passing in the context of all our previous interactions,
Mhm.
there's no way of quantifying the policy.
Mhm.
Is that
Yeah, I guess here the state space is just so large. It's like, all possible strings of text. So yeah, you have to just give it to the language model and then it gives you some distribution. Now, sometimes you can be in a state though, and you know that there's no, that certain actions are not valid from it. So a good example is like, um, well, let's look here. Um, so maybe right when you start the episode, this previous action doesn't is meaningless. So if you really want, you could like mask that action out or retry if it generates that action. Yeah.
Your earlier question of info problems,
Mhm.
with text-based stuff is that a lot of websites are created to be like understood by humans, and we're understanding it by looking at it, and it's all
Mhm.
visual. So if you get like the DOM or just like the HTML, it might not like give you the same type of information, and it might be much harder for the LLM to interact with the website that
Mhm.
way.
Yeah, yeah. Yeah, yeah, exactly. So there's this choice you have to make of like, do you represent everything as text? Do you use images? Do you have some mixture of the two? And yeah, it's not clear what is best. And yeah, certainly in some cases, it seems like since the web page was designed to be represented as an image, it might just be easier to have the model interact with the images. So yeah, that's a great question, and it'll lead into the second part. Okay. And then yeah, another thing to be aware of is that sometimes the environments can be specific again to a certain domain. So like here, if you train a really good model for this web shop environment, then it might be really good at web shop, but you can't really use it for anything else. So yeah, another thing you have to be careful of is how you actually design the environment so it's kind of expressive enough. If you're trying to build a general purpose agent. Okay, so let's go to the visual agent environments. And so here we just provide image observations as well. So as we saw before, you can do this web browsing, and this is exactly what I showed before with this mini world of bits. And yeah, it was from 2017. Of course, here, this environment lets you also have the DOM, the text-based representation, or you could treat it as a visual task. Um, Here's one with more realistic websites. So this is called Visual Web Arena, and it's actually from people here at CMU. And this you could think of as being a superset of that web shop environment that I showed you before. So they have their own shopping site here. They also have their own version of Reddit and these like classified ads, like if you've ever been on the website Craigslist. And basically they build an environment that simulates these websites, I think using like some open source version of them. Um, and then yeah, you could come up with this action space, which is like click an element, type in a text box or something, close a tab, things like that. And so this action space is kind of, it's fairly general, but yeah, it's also specialized to the web navigation. And then you could perform these different tasks like um, help me make a post selling this item and navigate to it, price it at $10 cheaper than the most similar item on the site. And then here you could see them visualizing like giving it to the agent, and the agent outputs some click action, and then you would go to the environment would actually perform the click, and then your agent gets a new web page. So again, you have to think about how you evaluate reward. So for each one of these tasks, if I'm remembering correctly, humans might have created the tasks, and then they also specify some function that you can run to like check the reward. Um, and so, yeah, in all of these cases, it could be a kind of multiple step task, and then you get reward at the end if you succeed. So, yeah, that's all I had for the visual environments. And I'll actually, in the agent part, talk about some challenges related to like perceiving the visual page. Yeah, so I'll talk about that briefly. And then finally, computer use. So I mentioned this idea of just having something that can not only do web browsing, but just anything on the computer. Um, so here's one recently called OS World, and they basically try to do what I said. So the environment now is just an operating system. And so in principle, you could do kind of you could at least perform any task on the operating system that, a human could. And then you obviously have to come up with some way of giving rewards and kind of make it into a self-contained task. So here's some examples. So on the top here, this one, the instruction is update the bookkeeping sheet with my recent transactions over the past few days in the provided folder. And so here it opens up the spreadsheet. It looks at some receipt, and then it starts filling out the spreadsheet. And then over here, it's like adjusting this code in VS Code. And then you could see here that they basically engineered this environment where, yeah, you have an operating system, you have multiple apps running, and then again, they have to come up with these tasks, and then they have some way of basically the agent says, I'm finished, and then they run a script and it tries to check whether the task has been completed or not. And then that will give them some reward. Mhm. Yeah, so here, a lot of these are still just prompting. So, so it's kind of seeing like the feasibility with the prompted model. And then, yeah, more recently, and I think one thing a lot of people are working on is to train the agents specifically for environments like this. Um, so yeah, here again, the observation is either a screenshot or an accessibility tree, they say. So they have some results which show like which one's better, what are the trade-offs. Um, and then here they have this extremely kind of expressive action space of just clicking or typing on the keyboard. Um, so then recently, well, we actually just released this yesterday, but this is work from our group. So we are interested in these computer use agents, but then like specifically for software engineering. So basically what we did is built an environment, which is VS Code. And then you could have a text-based agent, which gets kind of like makes tool calls and gets tool outputs. But then the agent can also just get like screenshots of VS Code. And so the potential benefit is if you imagine in VS Code, there's been all of this tooling implemented inside of VS Code. So like if you want to use a debugger, then all you have to do is like click on the debugger, things like that. If you want to do code search, then yeah, you can use like Command F or something like that. And so the idea is maybe you can keep your agent fairly simple and expressive, but then perform all of these different engineering tasks. And so again, to evaluate, you have to kind of specify a task, and then the agent has an action which says like, okay, this task is finished. Now I'm going to run the evaluation and get a reward. Um, so that's all I have for the environments. Hopefully this gives you some picture of some common environments. And again, these are ones that are trying to incorporate language models, and agents is a very general idea, so these obviously aren't the only ones. Any questions here before I move on to the actual agents themselves instead of the environments? Okay, so here, like I said, I was just putting kind of bare bones things to introduce. So first, I want to just talk a bit about prompting a model to be an agent and actually show you in a lot of detail how one agent does this called OpenHands. It was developed by Graham Newbig and others. Um, then I'll talk briefly about representing the screenshots and one technique that is popular now. And then I'll talk about a computer use agent that's been trained by the company Anthropic, and yeah, give you a bit of details about um, not how they train it. We don't know that, but just show you exactly what it gives you. So here to prompt a model, you have kind of three main things. So first, you again have this notion of a system prompt that we talked about in the prompting lecture. Um, and so this will just describe the task. It'll say, you are an agent. This one says you are an open hands agent. And then they have some like important information like if user provides a path, you should not assume it's relative to the current working directory. Instead, you should explore the file system to find the file before working on it. Um, and so sometimes this one's actually fairly short because they wanted to keep this agent very general, but you can actually influence the behavior a lot through the system prompt. One technique that's used is to basically, for this task of closing the pull requests, you could actually say like, okay, break down the problem into localizing the error, then running the test cases, then making a fix. And so by kind of putting that in the prompt, you're in some sense like telling the model, you're giving it a hint on how to solve the problem. Here again, they wanted to try to keep it kind of general. Um, and maybe I should give you a reminder here. So in the very first lecture, I showed this open hand system. Um, and the basic idea is, yeah, you have this kind of IDE, and then you have this window here where you can put in different things. And then this goes to a language model or to the agent. And so um, here we say like, let's add a retry mechanism to the script to handle this situation. Or maybe that's the agent saying it. But anyways, you can have this dialogue and then the agent can actually like take actions and edit your code and search the web and things like that. So that's what I mean when I'm referring to open hands. And their whole thing is open source, so you can look at exactly what they're doing. So then the second part is you need to describe which actions the agent has available to it. These go by various names, so you could also call them tools. Um, so here's an example where you want to tell the agent that it can execute bash commands. So they actually write this description. Here's one where they have a browser and it says like the browser has 15 functions, go to, go back, go forward, etc. And so, yeah, you can go in and you can look at all of the descriptions that they have, and then you can somehow provide this to the model, and then it now knows what the task is and what kind of actions or tools it has available to it. Then finally, you have to format the observation. This will depend on the environment. And then of course you have to, um, yeah, say the agent takes an action, then you have to, yeah, format the resulting observation. Something I'm not going into here, since it was just on the kind of basics, and I don't think there's a single answer for it yet, which is like some of these tasks are very long. And so you have to think about how do you build a kind of memory of what the agent has done so far. And the memory could be over just one trajectory, but you could even imagine like if you're in a new environment, maybe you want it to remember things across like multiple tasks or things like that. And so it can get very long. So broadly speaking, one thing you can do is just try to use a model with a really long context. And if it's a short enough task, then you just kind of build up this list of kind of messages and give it to the model. But this is one thing that, yeah, is still being looked into now, and it's still a challenge because as you can imagine, with these environments, you have a lot of information, like just in the observation. You might have a whole code, like file of code or something. Um, and then if it's trying to do some kind of long task, then the context can get very long. So yeah, that's a kind of challenge that people are looking into now, which is the kind of memory, you could call it. So I wanted to say a bit more about describing the actions or the tools. So it turns out that this pattern of making these kind of tool calls or actions is kind of popular. And it's popular enough that these different commercial language model APIs actually have a specific way to tell the model about these different actions or tool calls. So what you can do is you could basically specify in JSON the description of the command, and then you say like, here's the input type, um, here's the output type, things like that. And then this is a screenshot from like OpenAI. And so now you could tell the model about the tool. In their example, it's called get weather. And now the model knows that one option it has is it can output some call, which is like get weather with some arguments. Now, the idea is that you have to still implement the environment, which actually executes get weather, or in this case, executes the bash call. But I guess I'm just saying that, yeah, this notion of providing these different actions or tools to language models is a kind of popular pattern, and you'll see it in these APIs, so it's something to be aware of even as a kind of user. Okay, another really basic pattern to do is you'll have the model output this thought prior to making an action. This has gone by various names, but yeah, this is the basic idea. So here's an example. I think it's from the SWE agent paper where they prompt the model to output a thought, and then here's the actual edit action that it's making. So one thing people noticed, and we kind of saw it in the very simple agent, visual agent that I showed you, where it was really struggling to even click this one button, is that, yeah, at least models that haven't undergone specific fine-tuning kind of struggle with, you could call it grounding, which is they have some action in mind, but actually realizing it by like making a click in the correct position, they're not able to do that very well. So there's a variety of ways to fix this. One way is you could try specifically training the model. Um, of course, you have to decide then where the training data comes from. If it's just from one environment, then maybe the model might only learn on that one environment. So how you kind of train models and how you do it in general to even do basic things like clicking and typing in the correct place is something that people are looking into right now. What you can also do, it's kind of orthogonal or complementary, is you can add information into the screenshot. So this is a technique called set of marks. And the basic idea is, yeah, you just add on these marks associated with different items on the page. And then you can even give a textual description based on the HTML. And so now when the model makes a click action, now it could say, you know, click 11, and it would click this 45 comments here, versus having to say like click on these like pixel coordinates or something like that. Can anyone think of any trade-offs with the set of marks or any potential downsides? Or with this, should we always do set of marks?
Elements you want to retract was wasn't included in the one.
Yeah. So yeah, you basically assume that the things you want to interact with are in the bounding box. And so you could see here that maybe the task is like highlight the number of years or something. Then there's no box around 1 year ago. Or similarly, what if the task was like um, click on the second letter of the name or something? I mean, these are joke tasks, but the idea is the box kind of gives you this level of abstraction, and you have to make sure it's at the right level of abstraction. So one place where this comes up is in a very kind of dense interface. So for example, like say you were trying to do VS Code with set of marks. then like should you put a mark on each line? Should you put a mark on like each word? And then if you do, it gets very cluttered, just the whole page is marks. So yeah, sometimes issues like that come up. But yeah, in an environment like this, it's actually very effective and I think a kind of common approach. Um, okay, and then finally, I wanted to just show you this computer use model. So recently, there was a model trained specifically for computer use by this company called Anthropic. And they did something slightly different than what I told you before. So they don't necessarily take in a screenshot every time. They give the model an action, which is screenshot. That idea has come up in other papers, so they didn't like invent that idea. But anyways, so the model can choose to take a screenshot. In that case, it would get the screenshot, or it has these kind of basic actions, like it can do basic file operations or run a bash command. And if it does one of those, then it gets some textual output for like the output of the action. And the idea is that like although this is calling different, yeah, these different actions, they're still fairly general purpose. So hopefully the model can still do most things on a computer. Um, and they actually released like the um, kind of user facing code, I guess. And you could see exactly which actions they have. So like key, type, mouse move, left click, bash tool, and then here's their file operations, just basic things like view, create, string replace. So anyways, they have some cool YouTube videos of the model doing different things. So here they're actually having the model like fix this error in VS Code, and it's getting the screenshot of the I guess it's taking screenshots and then it's like typing in the editor. Um, and so yeah, you could check out their videos. It's not meant to be a advertisement, but it's fun to see what some of the more cutting edge models can do. Um, okay, so then can anyone think of some like trade-offs? Let's say you have a given problem, then like should you pick one of these text-based agents, a vision-based agent that has like a specific set of actions, or should you try to use this very general purpose computer use agent? Any like pros or cons with these different choices?
I guess the computer agent might make more dangerous mistakes. It has access to a wider range of tools.
Yeah, yeah, exactly. So yeah, I would think of it as like this, you have this trade-off between in like the flexibility. So the computer use agent is more flexible, but then that can come with issues. Yeah, one of them is kind of safety related issues. The other is at least currently they're not very good at even basic things like clicking. You know, that might change in the year of the agents. I don't know. Um, but anyways, yeah. So if you have a task that you want to do, like a specific task that you want to do really well on, and today, then yeah, the text-based agents can be very effective. And then a kind of maybe obvious trade-off is like if you have to use vision for your task, then uh, um, yeah, sometimes you want to just unless you're like a text purist, just add in the ability to like take screenshots. Um, and then you need a vision language model. Um, and yeah, otherwise, anything else? Mhm.
Question, so, you talked about screenshot, but what if it's a flat it's moving the item?
Mhm. Yeah, that's a great question. So that's another open challenge is the video models. Um, so it's something that, at least for these types of agents, is less explored right now. I think it might be in other domains, but yeah, even building the really good models for videos is a kind of active area. Mhm.
I think a con for all of them is kind of, they're very expensive.
Mhm.
A lot of information, just to basic.
Mhm. Yeah. Yeah, so these are very expensive. Yeah, the context can get very long when you give images. And yeah, especially if the trajectories are long, then um and each call is like doing thinking and things like that, then yeah, they can get very expensive. Mhm.
Probably it'd be better to have like a hierarchy of agents, like use multiple agents for like, a general purpose task and probably have like a larger, more general agent supervising them. So like for a particular task, you have a text-based agent do some work and then you hand it over to the general agent, which then hands it over to the vision-based agents. Like
Mm.
that way you're able to balance the cost because you don't want like the general agent doing everything. It's too expensive and it's also not very good.
Mhm.
But probably it's just very good identifying what is good for
Mhm.
these specialized subtasks. So that could be a possible workaround.
Yeah, yeah. Yeah, that's a great suggestion. So you could, instead of having a single agent, consider multiple agents. And so that's another, yeah, area that people are looking into. You could try just trying to go with a single agent and pushing that direction. Or you could say, okay, if we use multiple agents, what's the best way to do it? It could be having some kind of hierarchy. It could depend on what you care about. Like if you're trying to minimize cost, then you might have a different multi-agent setup. Um, so yeah, that's a great observation. Okay, and then as I mentioned, also just training these agents. So even basic fine-tuning, but reinforcement learning. If you go back and read the World of Bits paper and I think the web shop paper, they actually did train those agents. In World of Bits was 2017 with reinforcement learning. So I think there's a lot of cool ideas there, and probably we'll see things in the next uh, couple years, kind of realizing some of those and with the modern agents. Um, but again, yeah, me presenting things as being based purely on prompting isn't saying that that's the best way or it's going to be the way of the future. Um, but yeah, I want to just give an overview of the area and some things that exist today. Okay, so to recap, an agent, we defined it as some policy that operates in an environment, and you can use a language model to kind of implement the policy, a vision language model. And then we went over some environments and some really basic patterns for the agents. So that's all for today's lecture, and I'd be happy to take more questions in person if you want to go a few minutes early. And yeah, please have a good spring break, and I hope the rest of midterms go well.